Okay, let's dive in. Imagine reaching for your smartphone and, well, knowing it has the language smarts of those giant cloud-based AI systems.
Hmm.
What if it could truly understand and generate text just as capably, but, without constantly needing to phone home to some distant server?
Yeah, that sounds like the dream, doesn't it?
It feels futuristic, but today we're taking a deep look at Hyena Edge. It's a new technology aiming to bring this powerful AI directly to our devices.
And what's really interesting here is the fundamental hurdle we're trying to clear. The large language models making waves right now, incredibly powerful, no doubt.
Right.
But their core design, largely built on something called a transformer, presents some inherent challenges, especially when you want to scale them down.
Down to a phone.
Exactly. Something as resource limited as a smartphone.
Precisely. One of the main roadblocks, as our sources detail, is this concept of quadratic scaling.
Hmm.
Think of it this way. As you feed these models more and more text, more information, the computing power they require doesn't just increase steadily, it balloons.
Yeah, it really takes off.
The self-attention mechanism, which is crucial for them to grasp relationships between words, needs to compare every single word with every other one.
So
So,
you have a long conversation or a big document.
exactly. The computational cost becomes enormous. Technically speaking, it scales as ON, where N is the length of the input.
And if we look at the bigger picture, it's not just about speed, is it?
And no, not at all.
These models are also memory hogs. We're
Yeah.
talking about storing all the knowledge the model has learned, the weights,
Hmm.
and then these very large attention matrices, which also grow quadratically with the sequence length.
Right. And your smartphone, even a powerful one, has limited RAM.
Absolutely. Trying to fit these huge models and their memory demands onto a phone really limits how much context they can effectively work with.
But here's where things get really interesting. Liquid AI has stepped up with Hyena Edge. It's an attention-free model, meaning it moves away from that computationally intensive self-attention mechanism entirely, or mostly, as we'll see.
Right, built on their Hyena architecture.
Exactly, and specifically engineered to be efficient enough to run on devices like our smartphones.
So the goal today,
Our mission today is to really unpack how Hyena Edge achieves this, what makes it fundamentally different from these transformer-based models, and what the implications are for having genuinely intelligent AI living right on our personal devices.
this brings up a key question. How do you achieve sophisticated language understanding without relying on this core self-attention mechanism that has become, well, so central to modern LLMs?
Yeah, how do you do that?
The answer lies in the foundation, the original Hyena model,
Right.
which was introduced in a 2023 paper.
Okay.
Its primary goal was precisely this: overcome the quadratic costs for processing long sequences while still maintaining or even, improving performance.
Okay, so how did they manage that? What's the key innovation at the heart of Hyena?
The main innovation is replacing self-attention with what they term hierarchical operators built on implicitly parameterized long convolutions.
Okay, that sounds quite technical. Let's break that down a bit.
Let's do it. Imagine a standard convolution, like sliding a small window across your data, applying a filter.
Right.
Hyena uses very long convolutional filters. This allows it to take in a much broader context than a typical short convolution.
Long convolutions, got it. Now, what does implicitly parameterized actually mean in this context?
This is a really clever part. Instead of directly learning and storing the weights for these very long filters, which would require a massive number of parameters, defeating the purpose.
Right, back to square one on efficiency.
Exactly. The filter weights are actually generated on the fly by a small neural network, often just a simple feed-forward network.
Generated on the fly.
Yeah, and this generation process is conditioned on the position within the input sequence. So you can have these incredibly long receptive fields. The model can look back very far without storing a huge number of individual filter weights.
So it's a very efficient way to capture long-range context without that parameter explosion.
That's the idea. It avoids the huge parameter count you'd see in traditional approaches.
That sounds like a significant step towards efficiency right there. And I've noticed mention of the fast Fourier transform, the FFT.
Exactly. Directly computing these long convolutions would still be quite computationally demanding, potentially still hovering around that ON
Yeah.
level.
Ah, okay.
By employing the fast Fourier transform, they can perform these convolutions much more efficiently. It brings the computational complexity down to ON log n.
ON log n. Okay, that's a substantial improvement over ON from self-attention.
Huge difference, especially when dealing with longer sequences.
Okay, subquadratic complexity, that's a clear advantage. Now, the source also mentions data-controlled gating. What role does that play?
Think of it as a mechanism for the model to dynamically decide what information is important at any given point.
Like a focus mechanism.
Sort of, yeah. After the convolution process, the sequence undergoes an element-wise multiplication with gating signals. These signals aren't static. They actually depend on the input data itself.
Okay.
This lets the model amplify the relevant parts of the information and dampen down the less important aspects. It kind of mimics the selective focus you get with attention.
But more efficiently.
Exactly, in a more computationally efficient manner.
So, to recap, the core of Hyena moves away from self-attention, uses these implicitly parameterized long convolutions calculated with FFT for speed,
Uh-huh.
and then employs data-controlled gating to focus on the important bits. That sounds like a fundamentally different strategy aimed right at those resource limitations.
Precisely. The advantages are basically twofold.
Yeah.
Subquadratic time complexity, meaning faster processing, especially for longer stuff.
Right.
And sublinear parameter scaling with respect to sequence length.
Yeah.
So the model size doesn't blow up as much as transformers when you want more context.
Making it inherently more suitable for, well, resource-constrained environments.
Exactly that.
All right, so that's the foundation of Hyena. Now, how does Hyena Edge specifically take these principles and optimize them for our pockets, for edge devices like smartphones?
Okay, so Hyena Edge builds directly on this foundation, but with a very specific focus on the constraints you find in edge computing.
Right, the limitations of a phone.
Liquid AI's research emphasizes this, referring to it as a convolution-based multi-hybrid model.
Multi-hybrid.
Yeah, which suggests they might be integrating different types of efficient convolutional operators or maybe other techniques to really maximize performance on these kinds of devices.
And our source mentions they're synthesizing target architectures, or STAR framework. That sounds pretty advanced.
It is. The STAR framework uses evolutionary algorithms. Think of it like computational natural selection
Okay.
to automatically discover and fine-tune model architectures. The goal is finding that optimal balance. Minimize latency, use the least memory possible while still getting high-quality results.
So they're basically evolving the architecture for the hardware.
Pretty much. This automated optimization is how Hyena Edge was specifically tailored to the unique demands of edge hardware.
So it wasn't just a direct adaptation of the original Hyena. They actively evolved it for the specific challenges of phones.
Exactly. And a key outcome of this evolutionary process is the Hyena Y family of gated convolutions.
Hyena Y.
Yeah, optimized variations of the original Hyena operator, specifically designed to be efficient on-edge hardware. A notable difference, according to the source, is that Hyena Y excludes convolutions within the feature groups.
Which are part of the gating mechanism.
Right. This simplification likely contributes to further reductions in processing time and memory.
And the specific architecture they settled on for Hyena Edge involves a strategic combination, right? It's not purely Hyena Y.
That's correct. They achieved a balance by strategically replacing approximately two-thirds of the grouped query attention, or GQA, operators.
Okay, GQA.
From a very strong transformer baseline, a GQA transformer plus, with these optimized Hyena Y gated convolutions.
Two-thirds, you said.
About two-thirds, yeah. Which suggests they're capitalizing on the strengths of attention where it's most beneficial, perhaps for certain tasks or layers, while leveraging the efficiency of Hyena Y for the bulk of the processing. It's a hybrid strategy.
Aimed at getting the best possible performance on, these limited devices.
Exactly. Best of both worlds, hopefully.
Okay, so it's not a complete shift away from attention. They're intelligently integrating these Hyena Y convolutions. Now, what kind of actual performance are we seeing? Our source provides some specific data from tests on a commercially available Samsung S24 Ultra smartphone.
Right. This is where the rubber meets the road. How does it actually perform? They put Hyena Edge up against that GQA transformer plus baseline, similar parameter count on this phone.
And the results?
Particularly in terms of speed, they're quite encouraging.
Let's focus on latency, that feeling of delay when you interact with AI. What did the tests reveal there?
Okay, so across the board, Hyena Edge showed faster prefill latency. That's the time it takes the model to process the initial input you give it.
So right when you start the interaction.
Exactly. And this improvement was consistent across various common lengths of input sequences. Even more interestingly, the decode latency.
That's generating the next word, right?
Right, how quickly it generates the subsequent words or tokens. That was noticeably faster for Hyena Edge when the input sequences were longer than, say, 256 tokens.
So for those longer conversations or more complex prompts, Hyena Edge really starts to show its advantage in responsiveness.
Precisely. The source even points out an improved scaling of latency as the input sequence length increases.
Better scaling.
Yeah, for longer inputs, Hyena Edge achieved up to 30% faster decode and prefill times.
30%, that's significant.
It really is. Because as we expect more from on-device AI longer dialogues, summarizing bigger chunks of text, this difference in how performance scales becomes increasingly critical.
And surprisingly, they even saw a faster prefill for shorter sequences, too.
Yeah, even on the shorter end, there was an advantage in getting started quickly.
That's impressive. What about the other major constraint on phones' memory usage?
Right, memory. Hyena Edge also exhibited lower memory usage during deployment across all the input sequence lengths they tested on the S24 Ultra,
Lower memory.
which aligns with the original Hyena architecture's promise, that potential for needing significantly less memory than transformers for very long sequences. The specific reduction here might vary,
Sure.
but the key point is it's more memory efficient. Crucial for running these models on devices with limited RAM without causing crashes or slowdowns.
Okay, so it's faster and leaner, but what about the actual intelligence? Did they have to compromise on accuracy to get that efficiency?
The critical balance, right. And the findings here are promising. Hyena Edge, even after being optimized for edge devices, matched or even outperformed the GQA Transformer Plus baseline on a variety of standard small language model benchmarks.
Okay, like what kind of benchmarks?
Things like Wikitext, Lambda, HelloSwag.
Yeah.
These are well-established tests assessing different aspects of language understanding and generation.
So it holds its own on quality.
It seems so. This level of performance mirrors results from the original Hyena paper too, which also showed strong performance. So it appears Hyena Edge isn't just fast and small, it's also, well, smart.
So Hyena Edge seems to be carving out a unique niche. How does it compare to other efforts in this space, the realm of efficient LLMs? Thinking about things like flash attention or Google's Gemini Nano.
That's a great way to put it in perspective. Let's take flash attention first. Flash attention is very clever. It optimizes how transformers access memory on GPUs.
Right, focused on the hardware access.
Exactly. This leads to significant speedups in training and inference, and it's widely used now. But it's important to remember, flash attention doesn't fundamentally change the underlying quadratic computational complexity of self-attention.
Still ON.
Still on that. So while it makes transformers more efficient on powerful hardware for truly long sequences or very resource-constrained environments, Hyena Edge's subquadratic approach, that ON log n, might offer a more substantial advantage.
Okay, so flash attention speeds up transformers, but Hyena Edge is a different beast architecturally, aiming for inherent efficiency, especially for longer tasks or tighter constraints. What about Gemini Nano? That's also designed for on-device AI.
Right, Gemini Nano. Developed by Google, integrated into Android, also aiming to bring LLMs directly to your phone.
Yeah, I've seen that on Pixel phones.
It's a family of highly optimized transformer-based models, and it even includes multimodal capabilities so it can understand more than just text.
Pictures, maybe audio?
Potentially, yeah. It's deeply integrated into Android's system for specific functions, suggesting replies, proofreading, summarization.
Okay, so very task-specific integrations.
Seems that way. So while both Gemini Nano and Hyena Edge share the goal of efficient on-device AI, they take different architectural routes. Gemini Nano is still a transformer in its core, albeit highly refined.
Whereas Hyena Edge
Uses this fundamentally different convolutional approach we've been discussing. This likely means they have different strength, different performance characteristics.
and might be better suited for different types of applications or tasks on your device.
That's a reasonable assessment. The architectural differences could lead to variations in how they handle, say, very long contexts or different types of data input.
So Gemini Nano might be more focused on those tightly integrated specific features within the OS,
Perhaps.
while Hyena Edge's distinct architecture could potentially unlock other possibilities for on-device AI.
It certainly could. It opens up different avenues for development.
This all sounds incredibly promising for the future of AI on our devices. What are the wider implications if technologies like Hyena Edge become more prevalent? Why should you, the listener, really pay attention to this?
The implications are quite significant, I think. Firstly, it allows for a much more seamless and responsive user experience.
Less waiting.
Exactly. Imagine interacting with a sophisticated AI assistant that lives right on your phone, processing requests instantly without that noticeable lag from cloud communication.
And a major consideration for many is privacy, right? That keeps coming up.
Absolutely. Processing data locally means your sensitive information stays on your device. Your stuff stays your stuff.
Right.
You have much greater control over personal data
Yeah.
because it isn't constantly being sent off somewhere else. This is huge for apps handling private messages, health info, financial data.
All the really personal things. Makes
Yeah,
sense. What about situations where you don't have a reliable internet connection?
that's another key benefit. Hyena Edge opens the door for truly offline AI applications.
Oh, yeah.
Think about being able to translate languages on the fly, take detailed notes with AI help, or use a personal assistant even when you're traveling, maybe in remote areas, places with spotty or no internet,
Offline translation would be amazing.
wouldn't it? Or just having your assistant work regardless of connectivity.
And you mentioned the speed improvements earlier, that reduction in latency. That has to make a significant difference in how natural these AI interactions feel.
It really does. Eliminating the need to constantly talk to a distant server removes a major source of delay.
So much faster response times.
Yeah, in interactive AI apps, it makes the AI feel more immediate, more integrated into what you're doing, less like you're waiting for an answer from afar.
And finally, there's the potential for cost savings, isn't there? Less reliance on massive cloud infrastructure.
Exactly. By offloading computation to the edge, to your device, companies can potentially reduce the burden and cost associated with maintaining these vast cloud data centers for AI processing.
So it's a more distributed model.
Potentially more sustainable, too, for deploying AI widely.
Okay, let's try and summarize what we've uncovered in this deep dive. Hyena Edge presents a genuinely innovative, efficient alternative to the transformer models that currently dominate AI.
Right, the standard approach.
By using this convolutional architecture, these clever gating mechanisms, it achieves subquadratic complexity, needs less memory.
Which translates to better performance on phones, like that Samsung S24 Ultra they tested.
Yeah.
Faster, leaner.
And it manages this while maintaining competitive accuracy, holding its own against traditional models on those benchmarks.
And if we tie this back to the bigger picture, this isn't just a minor technical tweak, is it?
No, it feels bigger than that.
This advancement really paves the way for a future where we have more private, more reliable, and more accessible AI experiences directly on our own devices.
Moving beyond total dependence on the cloud.
Exactly. Towards a paradigm where sophisticated AI can live locally.
So as Hyena Edge continues to evolve, and with Liquid AI hinting they might make it open source, it really sparks the question, how might this fundamentally reshape the kinds of AI-powered apps we see? Not just on phones, but maybe in cars, wearables, all sorts of devices.